Hey guys, okay, so I want to talk about what happens basically, very basically, what happens with an extracellular infection with something like E. coli. Okay, so pretty much as we discussed, if you're going to get some sort of infection, it's going to be in your tissues first and not your blood. You're going to get scratched. You're going to walk through somebody's sneeze and get something up your nose, something like that in your throat. But unless somebody actually injects you into your bloodstream a pathogen, pathogens don't usually show up in your bloodstream. They start in the tissues, and then there's a possibility they can spread into your bloodstream. But nobody ever starts with just a bloodstream infection. It starts somewhere else in your body where your tissues have been compromised. Okay, so what we're talking about here is, okay, so here is basically your vessel, your blood vessel, and here's some neutrophils and some monocytes that are just floating around. Remember, we said it's like a police officer on patrol. They just kind of like swim up in your bloodstream and look for trouble. Okay, so here we have an E. coli, and I'm only going to give it one flagella, even though it has flagella all over. Okay, so somehow your skin is breached, and now you have E. coli in a cut on your arm. Okay. Your tissue-based cells, remember your professional phagocytes, which are your dendritic cells, and your macrophages, are already tooling around. And MO means macrophage. And dendritic cell, which I'm really bad at drawing. So yeah, I'm just going to put D for dendritic. They're actually modal. They tool around in between your tissue cells. So it's not like they're embedded in your tissue. They do move and in search of pathogens. Okay. So we're going to say, because this dendritic cell doesn't look very healthy, we're going to say, okay, this macrophage, now on this, you remember on this E. coli are PAMPs, okay, which are antigens that are pathogen-associated molecular patterns, okay? These are not found on host cells. So when your immune system sees these PAMPs, they know that it's not your cells. They know it's bacteria or something like that. Okay, so this macrophage is like, I see you, you're going down. No way, you're not going any further. So this macrophage swims over, okay? And it has, remember, MHC2, which we'll deal with later, but it has pattern recognition receptors, pathogen recognition receptors, right? So this has PRRs, okay? Which are little things here that will recognize this PAMP and will attach, okay? That's the whole thing about your immune system, is about attachment and destruction, okay? So it attaches. Now this macrophage engulfs all of this, okay? What else does it do after it engulfs this bacteria? Talk about over here. It releases cytokines. Remember, T helper cells are not the only ones that release cytokines. Every kind of cell in your body releases at least one kind. Okay, so this macrophage now is going to be like, help. Okay, it's going to release the cytokines. Woo. And the first thing it's going to do is going to turn on inflammation. Why does the first thing have to be turning on inflammation? Yes, it's going to be calling out the neutrophils because it's a bacterial infection. It's going to be calling out the neutrophils and the monocytes, because when the monocytes hit the tissue, they are going to mature into macrophages so they can also crunch down on all this E. coli that's there. Okay, so both of these have to come, but remember how your vessels are like tightly packed together with these cells. And so they're trying to get through. They keep bumping their heads because they can't get through. What's the first part of inflammation? Vascular permeability. These cytokines have got to start up inflammation in order to let the vessels open up a little so these cells can migrate diapedesis through the vessel wall into the tissue where they need to be. So inflammation has to be one of the very first things that happens. Otherwise, these cells will never get out of the bloodstream to be able to help, okay? So inflammation starts, woo, okay? With inflammation comes vascular permeability, okay? That causes swelling, okay? Because more, things are opening up. There's more interstitial fluid coming, more red cells and everything are coming. That creates the redness because the blood is now rushing to where it is. And within the blood are clotting factors, platelets, and things like that, which help with the healing process. But also blood helps flush out the pathogen from that wound. Okay, so it also is a chemical, more like a mechanical barrier of the innate system if you think about it. So anyway, and then what else is that? Redness, swelling, localized heat, okay, and pain. Oh yeah, okay. So the inflammation starts separating these. So all these macrophage or all these monocytes and neutrophils can come and help phagocytize all these E. coli's. Okay. Looks like the balloons from It, doesn't I? Should probably write. But this is not the way they're shaped. They're shaped like rods, so they're shaped more like this, but whatever. But anyway, these are the E. coli's that look like balloons, but so then we have these the monocytes come into the tissues, quickly mature into macrophages to become more efficient at phagocytosis. And they have these, and we have the neutrophils to come in, also phagocytize the bacteria. Okay, so that's your inflammation. Okay, these cytokines also grab the complement. What are, start up the complement cascade. So this one, what complement cascade would this one start? From a pathogen cell wall. It would set up the alternative pathway, okay? But either way, the complement comes, right? And the complement comes in, first off, complement ramps up the immune system, and it also ramps up inflammation. So now inflammation is even more, I'm trying to think of the word, but complement is like really ramped up now, or I'm sorry, inflammation is really ramping up here. So we have a lot of swelling because we have a lot of the vascular changing and things like that. So we're good with that. Okay. Complement also comes in, because remember, they're proteins. They come in and start sticking like glue to these pathogens, which allows more ease of phagocytosis. Okay, they make them sticky, so it's easier for the phagocytes to come in and stick to both the complement and the PAMPs. So it gives it more binding space. It makes it sticky and makes it easier for these phagocytes to eat the bacteria. Yeah, okay. So we've got cytokines. Now, acute phase reactants like CRP. These cytokines also, now these acute phase reactants are serum, they're in your serum, they just went back and forth, and all of a sudden there's inflammation. And they're like, okay, oh my gosh. First thing that complement, or the first thing that CRP does is start replicating, starts making more CRP, like crazy. So remember, your CRP and these other acute phase reactants, but especially CRP within 4 to 6 hours, start, that's the word I'm looking for, a huge proportion of them just continue to replicate until there's a whole mess that is measurable in your serum. That is why these acute phase reactants are so important in a laboratory, because you can measure the amount of inflammation by measuring these acute phase reactants. These acute phase reactants also come in and are opsonins. They stick to whatever to make phagocytosis easier as well. When we're talking about replication, another thing the cytokines do, when the cytokines also come and call for these neutrophils and monocytes, these neutrophils and monocytes all start replicating like crazy. So there's more of them that can go out and attack, because the more the better when you're trying to defeat an enemy. Okay, so we went through all that. Now when we're talking about back to this macrophage and all the macrophages, it's an extracellular bacteria. So what MHC are we talking about? These have MHC too, so they grind up these little pieces of E. coli and they present them, because these are professional antigen presenting cells. They present them on their cell surface. Okay, and right here ends the innate immune system. Okay, so that is the innate immune system kind of in a nutshell. All right, I hope that helps. See ya.